Okay, so in example 1, we are doing long division. So we're going to repeat x times what is negative 7x squared. So it's a minus 7x. So that's minus 7x squared. Notice when you use the distributive property, that's a plus 14x because it's minus 2 times minus 7x. Take the opposite and add. You get 2x minus 4. And then x times what is 2x? It's a 2. Notice that results in no remainder because they're identical. So the division answer is 6x squared minus 7x plus 2. They asked us to divide, and then the second thing they asked us was to use the result to factor the polynomial. Well, this is going to be, we know one of the factors is x minus 2, and we need to factor 6x squared minus 7x plus 2. So hopefully we can do that with trial and error. I got 3x minus 2, 2x minus 1. Don't lose the original factor of x minus 2. Because if you just wrote down 3x minus 2 times 2x minus 1, okay, if I cover that up, that doesn't multiply out to a 6x cubed, okay? All right, the division algorithm says if f of x is divided by d of x, you're going to get a quotient, q of x plus, and we do the remainder over the divisor, okay? So in example 2, again, I'm still on long division. We'll get to synthetic in a moment. If you want to divide x cubed minus 1 by x minus 1, I need to refresh your memory that if you're missing the x squared and the x, we need to insert a place value for it of 0x squared and the 0x. So we're going to ask ourselves, x times what is x cubed? You know it's x squared. Use the distributive property. So I get x cubed minus x squared. You take the opposite and add. X times what is x squared? It's an x. You take the opposite and add. And there's no remainder. So the division answer is x squared plus x plus 1. Now I have a little math secret here to share with you. Is that, do you remember you've been asked to factor a difference of two cubes, like x cubed minus 1 or x cubed plus 64, things like that. Well, we tend to forget the SOAP part and getting this piece of it. So here's kind of the good news. If you forget and say I had, x cubed minus 8, and I know that it's the x minus 2, but I can't remember the other stuff. You can do synthetic division and come up with it. So it's like sometimes if I forget, which I don't usually, but suppose I'm a student and I forgot, then you can actually use this technique. If you can't remember where's the plus, where's the minus. You guys understand what I'm saying? That's a really nifty backdoor entrance into your factoring, a difference or sum of two cubes. That's a smile. That's pretty cool. Okay. I think that's cool. All right, try example 3, doing long division. Okay? Do the long division. I'll give you a head start on me. ready to go. So x squared times what is 2x to the 4th? So it's 2x squared. Then I use the distributive property, and then I take the opposite and add. Well, what's interesting is both my 2x to the 4th and 4x cubed, they both cancel. And then this is a plus 1. Take the opposite and add. So now you have to remember how to answer the problem properly. This is 2x squared plus 1, and then it's plus the remainder. And the remainder is what you are left with divided by the divisor. Something I need to point out is you need a plus sign here. You can't, if you set it beside it, that's 1 times the fraction, not plus the fraction. So be careful with that. So anytime you have a remainder, you're going to need to remember to plus what you're left with divided by the divisor. You guys remember this? Okay. All right, synthetic division. Remember, you use synthetic division when dividing by an x minus a number, and we'll call it x minus c. Okay, so recall, use synthetic division when dividing by x minus c. So, in example 4, since I'm dividing by x plus 3, this really had to have been x minus negative 3. So the c goes in the box, but it has to be in the format of x minus a number. So this is negative 3 in the box. I have a 1. Notice I need to insert a 0 because there's no x cubed. Leave a row for numbers, and then you put a box under your constant because that's going to end up being our remainder. So I bring down the first number, and I do negative 3 times 1, negative 3, add the column. Then negative 3 times negative 3 is 9, add the column. Negative 3 times negative 1 is 3, add the column. Negative 3 times 1 is negative 3, add the column. Now, what we've done is we've essentially taken an x to the 4th divided by an x to the 1st. So by my quotient rule from the exponent properties, that's an x cubed. So this means my answer is x cubed minus 3x squared minus x plus 1, and then I have a remainder of 1 divided by, the divisor was x plus 3. Okay? All right, try example 5 using synthetic division. To make sure you didn't get too far and you're doing it the wrong way. There's no x to the 4th, there's no x cubed, there's no x. So you're inserting a bunch of zeros here, okay? So be careful. You have 1, 0, 0, negative 3, 0, negative 20. So what is the degree of my answer? 4. So this is x to the 4th plus 2x cubed plus 4x squared plus 5x plus 10. And what does 0 remainder mean? What does 0 remainder mean? Say it again.
There is no remainder.
Okay, there is no remainder. Let me ask you this. If I said I had 24 divided by 3, there's no remainder. That means 3 goes into 24 evenly, right? So this means x minus 2 goes into x to the 5th minus 3x squared minus 20 evenly, that there's no remainder, okay? All right, any questions on synthetic division? Okay, then we have something called the remainder theorem, and we did this last year. It says, if a polynomial f of x is divided by x minus k, then the remainder r equals f of k. So what I want to do is, let's go back here a moment, and let's look at example 4. The remainder theorem is saying this: f of negative 3 is equal to the remainder. Okay? Go back to example 4, and what this is saying is, now it does have to be of the format x minus a number, so you're really looking at negative 3. So take out your graphing calculators, and what I want you to do is, let's verify this, because that's a little surprising, I think. So we're saying that if x is a negative 3, so let's do negative 3 store x and press enter. Okay, put negative 3 store x. And then let's type in the polynomial in example 4. That was x to the 4th minus 10x squared minus 2x plus 4. And it's giving us 1. So the remainder theorem is actually very, very powerful, and it's giving us an alternative to, instead of plugging in negative 3 in for the x's and getting it to evaluate it, you can actually do, see how easy synthetic division is versus plugging negative 3, yuck, 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 in there? I can still get the answer by doing synthetic division and looking at the remainder. And so likewise in example 5, this is saying if I plugged in a 2, it's equal to the remainder, which would be 0. Oh, that's pretty cool. Okay, so that's what the remainder theorem is saying. What does it mean when r equals 0? That means x minus k is a factor of f of x. It means it went in evenly. Now I want you to look at the wording in example 6. It says use the remainder theorem. It doesn't say evaluate it by direct substitution, directly plugging a negative 2 in. It's saying use the remainder theorem to evaluate the following function at x is negative 2. So if x is negative 2, to demonstrate that you understand the remainder theorem, you want to do synthetic division and show that the remainder is equal to f of negative 2. Okay? So let's do the synthetic division. I bring down the 3. Negative 2 times 3 is negative 6. Add the column. Negative 2 times 2 is negative 4. Add the column. So what we're doing is f of negative 2 equals negative 9. On the next quiz, if you do direct substitution, you're going to lose all the points, because that's demonstrating you don't understand what the remainder theorem is. You need to make sure you're doing synthetic division and showing that the remainder is the same thing as f of negative 2, okay? All right, in example 7, it says let f of x equal x cubed plus 3x squared minus 2x minus 8. Show that the value of f of negative 2 is the remainder when f of x is divided by x plus 2. So the first thing we're going to do is the synthetic division. So we know the remainder is 0, But it's saying show that f of negative 2 is the remainder when it's divided. So this is a two-part problem. Now we need to go do f of negative 2. So this is negative 8, that's plus 12, plus 4, minus 8, that's 0. So f of negative 2 So f of negative 2 is equal to the remainder, okay? And so we've just shown that. Alright, so again, the remainder theorem says if f of x is divided by x minus k, then the remainder equals f of k. So now we have the factor theorem. And this is not a typo. Let me clarify what that's saying. A polynomial f of x has a factor of x minus k. IFF stands for if and only if f of k equals 0. I hope you guys understand this from geometry, that if you have a theorem that says if p then q, the opposite or the converse is not necessarily true, but in some cases it is, like in the Pythagorean theorem. If you have a right triangle, then a squared plus b squared equals c squared. The converse is also true. If a squared plus b squared equals c squared, then you have a right triangle. But that's not true for all theorems. So when you see this, this is a theorem. If and only if means if f of k equals 0, then I know x minus k is a factor. So you can go forwards and backwards with this. So in example 8, it says let f of x equal x cubed minus 4x squared minus 7x plus 10. Determine if x minus 5 is a factor of f of x. What would we need to do to determine if x minus 5 is a factor? What's the factor theorem say? It's saying x minus k is a factor if f of k equals 0, right? So how will I know if x minus 5 is a factor of f of x? Stephanie?
You could substitute 5 for x.
Good. One way is substitute 5 for x and see what would we want to have happen. Have it equal to 0. The other way is, couldn't we do synthetic division and see that the remainder is 0? You can do it either way. Directly plug in 5 or do synthetic division. I'm going to go ahead and go with synthetic just because it's a little bit faster for me. And then what I want you to do is, I don't want you to just say yes or no. I want you to say how you know it. X minus 5 is a factor of f of x because f of 5 equals 0. Getting f of 5 equals 0, you can do it either the way that Stephanie suggested. You plug in that x is 5, or you can do your synthetic and use the remainder theorem. Okay? Alright, last example says, show that x minus 2 and x plus 3 are factors of f of x. Then find the remaining factors of f of x. Something I need you guys to work on is the instructions of the problem. So when you do tonight's homework, and since this is a one-day lesson, this is due tomorrow, some of the homework problems will say, find the remaining factors, and then you're going to do it like we do this. But some will say, completely factor f of x. Well, that's something else where you have to use the given factors as well as the found factors to completely factor it, okay? So if I want to find the remaining factors, what I'm going to do is I'm going to do synthetic division twice and take this down from an x to the fourth. I'm going to do it once and get an x cubed. Then I'm going to take the x cubed and do a -3 and get it down to an x squared, and then we know how to factor x squareds, okay? So here we go. Bring down the 2. 2 times 2 is 4. Okay, good thing we got 0. That means it went in evenly, and it should have, because it told us, the problem said, show x minus 2 and x plus 3 are factors. So it is. Now, I'm going to take the -3, and this is now an x cubed, isn't it? Because I took an x to the fourth divided by an x to the first. So then I'm going to take that answer and take an x cubed divided by an x to the first and get it down to that x squared. So I bring down the 2. So x minus 2 and x plus 3 are factors of f of x, and I know they're factors because the remainders were 0. Then it says, then find the remaining factors. Well, this 2, 5, and 3 represent 2x squared plus 5x plus 3. And I can factor that. I'll use trial and error. Remember, check your work when you factor. Now, if the problem had said completely factor f of x, I would have had x minus 2 times x plus 3 times 2x plus 3 times x plus 1. You would put them all together. Okay, on the homework they do ask you some of those. All right, let me go over this one more time. It said show x minus 2 and x plus 3 are factors. That means doing the synthetic division and showing that you have remainder 0. And then this results in an x squared degree, and then I know how to factor that. Okay? Now on the next screen, when a polynomial is divided by one of its binomial factors, the quotient is called a depressed polynomial. Not because it's sad, but because we're taking the degree down 1, okay? A depressed polynomial has a degree less than the original polynomial. This polynomial may also be factorable, which would give you other zeros of the function. So keep in mind, when you do synthetic division and you reduce down that degree, then with quadratics, even if it didn't factor, we've got quadratic formula in our tool belt that we can pull out to still solve it if we need to.